So welcome for the second part. So Jean and I will be presenting the foundation of our ML platform, GetYourGuide. So my name is Theodore and I'm French, working at GetYourGuide since August 2021 as a data scientist in the recommendation and relevance team.
Hey everybody, my name is Jean Machado. I'm from Brazil. I'm in Europe now for 3 years, working at GetYourGuide, and there as an engineer facing solving problems around recommendations, search, and ranking, basically.
So in the next 25 minutes, we'll present how we laid the foundation of our ML platform at GetYourGuide. So to make it easier for our data scientists to iterate through the cycle of first ID, then coding, then experiment. So if you have any question, please write it down in the chat and we will answer them at the end. Okay, great. So this is the agenda for this presentation. So first, Jean will start with an introduction about GetYourGuide. Then we will dive into the use cases that we have in data science in our company. And Jean will also present how we iterated on the deployment of our models and their limitations. Next, we'll present the foundation of our platform. In the first part, we'll explain how we leverage MLflow, to manage our models. And then in second part, Jean will explain how we use the templating to bootstrap our project with the good practices. And we'll conclude with some final words and open for questions.
Yeah, so to talk about our machine learning platform in GetYourGuide, first we have to introduce GetYourGuide, I guess, for European audience like this. You probably know the company, but in case you don't know, so GetYourGuide is building one of the biggest marketplaces for travel experiences. We are connecting millions of customers over our catalog of more than 40,000 experiences worldwide. To summarize, our mission is to give access to the world for incredible experiences, and to get more concrete about what that means is, so if you want, for instance, to skydive on the Sugarloaf in Rio, or you want to see the sunset of New York City from the top of the Empire State Building, or explore food markets on Hong Kong, GetYourGuide is a place to find this kind of activities, and it's just some few clicks away of you. As you might guess, the travel sector was pretty much hit by the pandemic. So we took this time as an opportunity to invest heavily on our tech foundations, to be ready for the market rebound. And the machine learning platform is part of this investment.
So back to me. So now that you have a kind of an idea of what the company is doing, I will tell you a bit more about how we are using ML at GetYourGuide. So actually, our data science team started 5 years ago, and during this time until today, the amount of projects that we own grew. And so we use machine learning in different areas. So for example, we use them to rank the activities we propose, to show on the top the most relevant from our inventory. And we show them on the different landing pages, and also on the search result pages. And see, you can have an example here. You can also just Google GetYourGuide and we'll find also the website. We also use machine learning to recommend personalized activities to our customers with panels that we distribute also on the website and on the app. We also use machine learning to help the tourist to discover a destination and find the best activities on GetYourGuide with paid search, the most famous one with Google. And also we also use ML for demand forecasting to predict to try to predict what will be the demand, so for pre-buy tickets, and also simply for planning. We also use ML for automatically labeling our inventory of activities. So in total, we have currently more than 20 projects that we need to currently maintain, and which is distributed among 2 teams. And we also have some models that are in other teams, and we also need to, from time to time, maintain. And so as you can see, we start to reach a critical size. And so for that, to try to stay aligned between the different teams and the different projects, we agree on a set of principles that we all follow. And we kind of split them in kind of 6 pillars. So the first one will be about the strategy. So how do we prioritize the work? And so, for example, we favor business value over state-of-the-art models. The workflow, how do we plan our work? So we incorporate the data to inform our planning dynamically. The third one will be about the model, how we build our model. So we value small iteration of existing model. And finally, also the performance is only proven online with A/B test, which is very important for us. Then the fourth one is about QA. How do we assure the quality of model? So if we are building, we want to build solid and resilient deployment. Then we have the engineering principle. How do we build, basically, how do we build our infrastructure? And we want to make sure that our work is reproducible and also modular. And finally, the stakeholder engagement. How do we engage with our partner? And we want to promote and educate our partners across the company about the data product mindset. So in a retrospective, we show that for 2 of those, for 2 of these dimensions, especially the QA and the engineering, we were not up to standard. So if you are building a model maybe just for research and you are the only one using it, it might not be a big deal if you have a broken model or for some days. But for us, it's quite critical because if one of our models is down, then it will affect the website and ultimately our customers. And that means we are losing potential revenue. And this can go really quick, fast. So in the magnitude of thousands of euros for every hour our model are down. So we agree that we needed to improve this dimension, and this is what this platform is about. So now Jean will explain a bit more about a different approach that we have to develop and deploy our models.
So as you said, we've been doing machine learning for around now 5 years, and until 2019 around, we've been using this approach of notebooks first and to go to production. And basically, notebooks are great, indispensable for us. They are widely used by ML practitioners. They have a very low entry point for people. You don't have to install a system in your machine to start doing machine learning. You can just open a tab in your browser. They are great to start new projects, prototype ideas, and also they have amazing visualization for non-tech people. So they are great and very necessary for doing data science, but they have also some features that are not very suitable for going to production. For instance, you can, most notebook solutions, you don't have proper version control. It's also not the best platform to do reuse. And also it's not the right place to do tests. You don't have the infrastructure in place to do that. Notebooks then are very easy to break. In summary, if you are going to production with a notebook running your system and you open that notebook and accidentally type something, I'm very good at typing stuff wrong in notebook cells, and that's very easy to break your system. And in our case, break your systems really means like stop ranking relevant products for when the user searches, or not showing noise in our recommendations, or even like paying a lot of money to Google to bet in the wrong ads. So there's clear side effects that for us are not make it a not good decision to go in that direction. So, and also they are, so they actually go into production with notebooks is not aligned with our principles. We cannot also build increments of code and maintain it for a long term, like with teams maintaining it rather than individuals. As Theo said, if you are just one person working on a research, the constraints are very different. So to be truthful to our principles, we saw that we needed an improvement. Next slide, please. So the second approach we took towards improving this system was, this was made like from 2019, 2020. We ported our code to GitHub, and that then removing the necessity to run notebooks in production. Or the workflow looks more or less like this. You have some working piece of code in a notebook, then you port it to a library. But still then there is a question on how you deploy it. And we opted for the simplest at first to be incremental. So we build it as a Python library and basically do a manual deploy to a S3 bucket that can run then in our production infrastructure. Yes, but this approach also has its limitations. When you start from a GitHub empty project, you have like zero out-of-the-box automation for your the quality aspects of your project. That makes also means that the different projects will have different ways of automating, and they will look very different. People will find diverging solutions. It's hard to onboard people in such a different set of engineering practices. So given that everything also starts from the zero ground, most of the solutions ended up doing manual deployment and also manual deployment for the bucket. You can see how that can break very fast. Just by doing enough times manual deployment, you're gonna break it eventually. It was not only once that happened. We were building a testing model and somehow wrote in the production location, so you broke the system this way. Yeah, that's two dimensions or problems with this approach. The third is that we don't have actually tracking. We are also of our parameters. We are in the dark to know which parameters the data scientists use to tune the model, all the learnings that happen that led to the model to be what it is. If you don't have that tracked, other people joining your project might have to relearn these things, and yeah, that just makes it much more expensive and hard to collaborate. So all these problems led us to the need of to the conclusion that we need to think on machine learning more holistically in our thus the need of a machine learning platform. Next.
Yeah. And so now I will present more about the platform and so what we built so far. So we'll break it down in two parts. So first, I will talk a bit more about how we make sure that that we are making machine learning reproducible. And so for that, we can say that actually, if in machine learning, if you just have the code, usually you cannot go that far. It's bad. But if you have the code and the data, it's already better because at least you can try to reproduce. But what you expect is have the code, the data, and also the executables. So with that, you are kind of understand what are the libraries that are needed, the version of them. And so this is a good way to make it reproducible. Finally, what you should have as the gold standard and what we should aim for is to have the code, the data, the executable, and also the logs. So with that, you are able to iterate faster because if something is broken between two iterations, then you just need to compare the version between the two to be able to fix it quickly. The handover are faster also because you have everything that you need to understand what happened previously. And also, if you want, for the scientific method approach, this is the right way to improve our model, to be able to reproduce each steps that led to this point. And so to help us with that, we use a new tool, and would like to introduce you to MLflow. So we leverage MLflow, which is an open source software, and the goal of this software project is to have a kind of platform not limited to few framework or also company infrastructure. And these tools is really useful for us in two areas. So first, it allows to log the metrics, the parameter, and also the output parameter, output model that we train. And this is with the tracking module from MLflow. And also, we are able to see the different, we can have an overview of all the model that we are currently using in production. And so for that, they have the model registry concepts with MLflow. And so with this, we are able to make it reproducible because with that, we have the code version that we are using for our training, because with the Git hash, we can log them in MLflow. We have the data that we store, and we log the path to make sure that we know where it's coming from. We have the executable, which is the Docker image that we also is logged with MLflow. And finally, we have all the logs that are linked to the MLflow and also pushed in a nice UI. And I will show you how it looks like on the UI. So for the tracking, so all the experiments, this is an example of an experiment. So a set of runs that we have, that you can have. And so here you have in one dashboard all the runs that you did, and you can see the different parameters that were used, the different metrics, and you can also order them by parameters, filters, etc. And you see when it was started, who was the user, etc., etc. And the second one is about the MLflow model registry. So this is a dashboard where we see all the model that we have in production, and also you have a stage for each of them, so we know if they are in staging, production, or archived. And by also digging into that, we can see like the different version from when to when they were in which stage, who changed them from stages, and also go back to the training and see the metric that were used, the parameters, and the logs. Okay. And just to give you a small example, like how it looks in the code, it's actually fairly simple. So you just import MLflow, and then you can just, let me put the pointer, you just with MLflow start run, and if you want to log a parameters, you just log a parameter. If you want to log a metrics, etc. And once you have a model that you have that you want to fit, then you can log the model by saying with the model where you want to have it saved, and if you want to register a model to have it in the model registry, you just say how you want to have it there. So a very, very interesting tool.
Yes, we'll talk now about the second part of the puzzle. So we see reproducibility as key for a platform, but to have it and also being able to deploy to production reliably, we have to increase the amount of automation we have on our systems. And a concept that summarizes this automation concern is MLOps, which was originally derived as a derivation of DevOps, which was a practice of summarizes machine learning operations, more specific to machine learning rather than DevOps. And but a central tenet of this ops movement is that every change we make in our code base in the master branch is ready to go to production. It's like a production valid change. That improves a lot the software engineering practices, and we believe that it can improve also our machine learning practices. So not only every change should be able to go to production, it should go to production automatically, which requires, and to do that, it requires some automation in place. not to start from zero with the GitHub repository. To solve that problem, we came up with a solution of a template that I will explain you next. So in GetYourGuide, we have an internal tooling that is used to speed up the development processes. Like if you want to set up a service or so on, you can use this tool. And it basically contains a templating on steroids functionality, which allowed us to create our own machine learning service template. And this template then it sets up a skeleton for our machine learning project, but also creates the GitHub repository, creates the AWS infrastructure necessary to run this model, and integrates with MLflow. And it also adds CI/CD. So CI/CD is basically the practice that allows us to go to production automatically while making our systems, making sure that our systems are working. I will explain you then in the next slide it in details.
Sorry. Yeah.
So every change we do in our GitHub repo that contains a model will then pass, using our CI/CD pipeline, it will pass through a series of checks. And if all these checks are positive, they will end up in production, basically. So our first series of checks are unit tests. We set up some by default, but the data scientist then is desirable that he continues building new tests, and we do also style checks, type system checks with MyPy, and security checks to see, for instance, if you are using an outdate version of a dependency. And once all of those checks are done, we trigger automatic training that, if also succeeds, we then go do automatic deployment. In the next step, we have a visualization of this process. So I'll start with a notebook. The data scientists do the exploration, and we reach a point where we say, hey, this is a serious project. Let's move it to production. So at that point, the data scientist basically bootstraps a new service. It creates all the infrastructure, and at every change, we trigger an automatic deploy that, if succeeds, trains our model and saves it into MLflow. And from MLflow, then we are ready to distribute to many other sources. MLflow makes it, the MLflow registry is the place where our model resides and can go to production then. Yeah.
So to conclude, so as we grew our data science teams, we need to refine our process and to make it more sophisticated. So to do that, we integrated good software engineering practices, and we also added some twist to be able to adapt to machine learning, especially with MLflow and this automatic training. And with that, we can help our data scientists to first build faster by focusing on the model and the data, and not on the infrastructure and setting things up. So instead of needed a few days to be able to start a new project, then in 10 minutes you have it ready and set up. We are able to deploy safer with automated tests and the CI every time, and also we have automatic documentation of the experiments that we are doing thanks to MLflow.
And regarding the next steps for the platform, right now the teams are in the process of porting the projects we have to the template. And at the same time, we are looking into real-time predictions. And that's a feature desirable for real-time personalization. So we want to really react for the latest interactions of the customers in the website. And the platform is just the right place to iterate on that concept. We are also we already foresee the need of a feature store. So as we add more and more models, we want to reuse the features that they are composed of, and so we need a place to set them all and be able to retrieve them. And yeah, we are continuously looking into monitoring in our systems. It's very easy for the models to drift in production, and yeah, that's something we will be continuously investing on. Yeah, the last slide, this basically completes our presentation. If this kind of work also sounds interesting to you, you must know we are hiring, and the link is just in the slide. You can access it. And now we are open to go through the questions.
Okay, thank you very much. So one of the questions that was asked by Magdalena was, are you running MLflow on Databricks with a smiley
Yes.
face? Yeah. And then,
so,
yeah, do you want to say something?
Yeah, I just wanted to say, maybe for the people who do not know, Databricks is kind of a data platform provider, and which also provide a way to have a centralized notebook which run on cluster and be able to use Spark, and also they also propose manage MLflow. Yeah.
A small remark by Abdul. Would be nice to have a whole workflow summary from hypothesis idea to fully automated in production. Is that a possibility, or
actually
comment?
Yeah, we have we wrote a blog post which should go live in the next month. So, and we will go through exactly this whole process of going from hypothesis to ID and then going to production with that. Yeah, that should answer your question.
Another question by Dimitros. I'm not exactly sure what he's referring to, but why have you made your own? There are AWS, SageMaker, and Azure ML. I mean, you use Flow in some sense. So.
Yeah, we are picking the pieces from many open source projects, and actually we have to already take into account our legacy or the way that we do things. Databricks is at the core of our operations. So MLflow is just a natural follow-up from that, and we still can leverage SageMaker to go to production. That's actually one of the tools for our real-time inference that we are analyzing. But yeah, so we are for sure not inventing everything at home.
Okay, so yeah, sure.
Yeah, we do not try to reinvent the wheel, and actually we are not building our own, we are more assembling our own. So we are taking the parts of the different things.
So another question by Abdul, what do you mean by automatic training? AutoML, or why not use some MLOps framework? But then you just basically mentioned, I think, your MLOps, right? I think the question basically answered itself, or do you want to comment on this?
So we are not using AutoML, but what we made by automatic training is when you have when you push something into the GitHub repository, it will automatically run the test. And if the test pass and you are also pushing to master, so we don't want to, so when we want to have a new basically model by pushing a new feature to master, then it will automatically, that's what I mean, automatically will trigger a training on the whole data set.
Okay. So a very elaborate cron job. No, I'm just kidding. So another question, are you using something like cookie cutter for templating? Probably that wouldn't be enough for the thing you achieve. Or?
So cookie cutter is a really good example. So we are not using cookie cutter, we are using Jinja behind the scene, which is kind of the same thing. But what we have with GigDev actually is more than that, because it's also basically already setting up the infrastructure. So we are connecting with MLflow, we are connecting with the Databricks, we have the secrets managed, we create the ECR. So all this thing is already pushed together directly. So you don't have to do this, you just have to run gig dev bootstrap. So yes,
Okay.
exactly. Cookie cutter alone will not be enough.
So I don't see any more questions, and I don't have any questions either. And I didn't see any questions on YouTube. YouTube was sort of quiet this time. Oh, there is another question. Can you speak a bit about any challenges you have faced with understanding utilization of the deployed models and how you've addressed them? I'm not. Do you understand what is meant? I think the challenges in understanding the utilization of deployment, right? So
not sure.
I'm not sure either.
Can you rephrase, Brent?
Yeah.
Oh. Yes.
Well, one thing to say is one big challenge is to have the right data in place. So we are also like at this point putting on hold all our iterations on some specific models of recommendations because we still don't have the data to see if our changes are being affecting our pipeline in a correct way. So the teams and the teams that own these events and sending this data around are distributed. So there are many social challenges around just monitoring your model and see if that's working in the right direction. I'm not sure if that exactly answered your question. Maybe you have another take on it, Theo.
Yeah, so if you've seen zombie model accumulating over time, so actually we have like a quite event driven, so we know the number of requests that have been sent, and so each time we have a new request, so we know we are able to measure how requested our models are. So they are not getting zombies. Definitely, they are heavily used. But what is sometimes challenging is moving from one model to the next with a new API or things like that, because getting all the consumer of our models to adapt to the new model, which might need new parameters or things like that, is what is challenging, because each team has its own priorities and things like that. But that's, yeah, it's not specific to ML. Any kind of microservice architecture kind of have these challenges, I believe.
Okay, there are a bunch of new questions. Theo, do you see them?
Yeah. So Abdul, what framework monitoring do you use for A/B testing? So not us, but GetYourGuide built its own framework for A/B testing, where we are basically able to flip the coins to be able to test new features, and is used heavily by a lot of teams, actually, from design to machine learning to also backends. And for the monitoring, maybe Jean, you can answer that better.
I wasn't sure if it's monitoring for A/B testing specific or monitoring in general, but our tool for keep an eye on our systems is Datadog, the main one. There's other tools like for monitoring how our events behave, but Datadog is the biggest one.
And question from Brian: is there any concept of ownership of particle? Sorry, is there a concept of ownership of particle models in your platform? Extending and creating. So yes, the model are owned by teams basically, and they are responsible to keep them running and keep them healthy, basically.
And they are mission teams. Like for instance, our team is recommendations and relevance. There's another team taking care of our ads, and so they're kind of clustered around domains, and yeah, the team owns them basically.